Okay, so from yesterday, can anyone name a part of a bone? Long bones is the best example that you can give. Epicondyles? Or epiphysis?
Yeah,
Epiphysis, okay. Okay, that would be certainly a part of a bone. Okay, so there's that what you're talking about. So, is there anything that stands out in your mind that's true about cartilage? Okay, it's found in between joints, that's true, but the best place to find that would be in between, as you can see, that of long bones. So, besides being on the ends of long bones, is there any other function that cartilage might have that you would be aware? Because one of the things we said yesterday, it's very, very painful if something like this happens to an individual. Like we said, especially in your knee joint or in between your vertebral column, if you lose this substance. What's that? Not the bone marrow. So that articular cartilage, if you lose that, you could say you lose that function of, essentially you call lubrication, like inside of the engine of your car. So what happens is you're going to build up heat inside of there, but the oil provides a lubricant in there that keeps your engine from seizing up. This has a very similar function, and it will be very, very painful if you lose that cartilage in there, okay? So again, that's found in the end of long bones. So the epiphysis, if you can try without looking, is that the end or the shaft of the bone? It's the end. So you have epiphyseal plates as well, so that means the diaphysis must be the shaft, and it is, okay? And then this is what's actually attaches to a bone too, not just because of different structures on there. We talked about this yesterday. A river delta. Okay, what muscle are we talking about and where is that found? What we talked about yesterday. The deltoid, where's that found? It's in the shoulder and it actually lifts your arm like this. There's many different motions that you can find. There's going to be, this type of a motion up and down like this, and you can actually supinate your arm, pronate it like this, and we had also talked about the functions of bones. Okay, so can anyone give me a brief overview and start naming some of those 5? Some of them are what I would think are maybe pretty obvious, maybe others really aren't. So what did we talk about yesterday? There's 1, protection. 2, support. Movement. There's 3. Not so much nutrients, minerals. Okay? So if that's what does it do with minerals then? We said parathyroid hormone and calcitonin was your teeter-totter. So that calcitonin does what with calcium levels? Yeah, it pushes it in there, so that means bones store minerals. Then the last one we talked about was with someone who might have leukemia. They might require this as a process. So that BMT was called what? That bone marrow transplants. That must mean you find bone marrow inside of bones. There's your 5 functions, because bone marrow produces blood cells, whether it is platelets, whether it's red blood cells, white blood cells, and probably eosinophils would be another one. For some of you, you're going to take a class called immunology, probably, and if you're going into that nursing field. And their common term for that is called, there's 4 types. There's what you call, I think, when we say IgA, IgE, IgG and IgM, I think. So that Ig stands for immunoglobulins, and that's, in short, saying that is your immune system. And if you know anything about your immune system, who can we pick on in here? Nobody? Oh, okay. So, for instance, this young lady's riding her bike around town, has her biker shorts on or something to that effect, wipes out on her bike, skins her leg really bad, okay? So you may get a bacterial infection from there, or different microorganisms can get inside. Your skin is a very good barrier for protecting yourself until it gets broken. But, so it gets broken, your immune system cleans that out pretty well, along with your lymphatic system. Years later, you'd expose to that same type of bacteria. Are you trying to catch up from behind with your immune system, or is it already up to speed, do you think? It's already up to speed. That's why people choose to get vaccines too. Because what that does is if you have a type of virus or a type of bacteria, you also have memory cells in there, okay? And what they do is they're genetically, let's say, refined to take care of any virus or bacteria that you've already been exposed to, okay? That's another type of immune cell that you would run across, and all of them are produced in your bone marrow. One of the functions of bone. Okay. So sometimes we can be or get let down by some of these if the body is under too much stress. It would take a really large amount of stress for something like this to break. But as strong as bones can be, the human body can only tolerate so much. So should something like this unfortunately happen, you can have a break in the shaft of the bone, that's where a compact bone is, or at the end where the spongy bone is. So how or why can we make that presumption that that spongy bone is at the end of a bone? Yeah, because it's talking about the epiphysis. That's correct. So then by default then, if you're talking about the diaphysis, then that's going to be the shaft of your long bone, whether it's your tibia, fibula, humerus, radius, ulna. Any one of those are good examples of long bones. I want to do one more. Where's this going to put us? Okay, good. Does everyone have this content that wants it? Okay, so then, all right. So, I don't know. I think many people have different philosophies when it comes to, per se, giving your dog bones, actual bones to chew on, okay? So when you're talking about throwing your scraps or your bones to the dog, what comes to mind for you people? Give me an example of some bones you might, just give it to the dog. And maybe you don't, but we're saying that you do. Anyone? What type? T-bone. Okay. So beef or T-bones, yep. So if it's not beef, it might be something else. What would poultry be? Don't be afraid. Don't be afraid. Yeah, don't be afraid. You said chicken. Don't be afraid. Yeah. Okay, so chickens, turkeys, and then there's probably, we're going to skip the sheep because I would just say, ew. Ew, sheep. Is you that's disgusting and you the sheep, is that spelled the same, E-W-E? I don't know. We'll just say that they are. That's why I said, ew, let's not talk about sheep. And then finally, what's the last bone that you'd find on a farm? Yeah, swine, okay? So I think it's perfectly okay to give ham bones, okay? And I think you can probably do that with maybe even just different types of antlers for your dogs to chew on. Giving them chicken bones it's theorized that that's not a good idea, but because they can splinter and fracture. But per se, if you do that, are these animals, your pets or dogs, are they chewing on the bones because they like chewing on that? There's something else that they like about that bone, do you think? It's actually something else they like, the bone, not just chewing on it. Something that tastes really good to them. The marrow, that's right, okay? So what they want to do is crack that open and get to this marrow, because to them, it's kind of like probably candy to them, and it tastes really good, and that's why they want to get to that middle to get to the marrow. All right, so where is that marrow stored? Yeah, it's a hollow chamber, but what is that hollow chamber called? Well, medullary cavity, and it's actually found in the diaphysis of a long bone. Okay, then any type of bone cell, okay, is just going to mean an osteocyte, okay? So we know that because if we're talking about an erythrocyte, we know it's a cell because it ends in that suffix. The erythral portion means blood, actually red blood. Leukocyte also means, of course, a cell. The leukeal portion would mean white blood cell. And of course, this is no different. There's actually two different types of bone cells that have a specialized function that you're going to be responsible for. One's going to be called osteoclast and osteoblast. That's just a deeper classification on what an osteocyte is, because what happens is your bones constantly reshape themselves, okay? And that's just a natural process. We're going to be going over bones of the skull here shortly. And what I mean by that, if we are talking about how these bones can be reshaped, what we mean by that is, for instance, these different what do I want to say? I think, well, we're done with that. I think this light is probably causing a shadow. I think you'll be able to see it. There we go. See it better on here now. Like these zygomatic processes here, that constantly gets reshaped by different two types of bone cells, your osteoclasts and your osteoblasts, okay? And what that means is, if I remember right, I believe that to build bone tissue is your osteoblast. I think keep the B's together with that. Then osteoclast is a type of bone cell that destroys that. And when we're talking about destroys or remodeling, it's just hydrochloric acid that starts to dissolve bone tissue. And if it's going through your mind, oh my gosh, you can't have acid destroying bone tissue. Well, yes, you actually need to have that happen, because one of the things that we talk about, that as we age and get older, what happens to, per se, a muscle mass should you not use that? What happens to your muscle mass? It decreases, okay? That's the idea that you've probably heard. Well, if you don't use it, you lose that muscle mass. Well, what happens, the skeletal system is really no different. If you are a very active person, and then all of a sudden you're not active anymore, your bones are going to reshape themselves because they're not being put through different types of stresses again. And that'd be very common for astronauts that are at the ISS. Where would the ISS be?
International Space Station.
Yeah. Good thing you didn't say in-school suspension. And maybe they did at one point, but that's not where they're at. They're at the International Space Station. So why would they lose muscle mass and possibly have problems with bone tissue?
Because they don't have gravity.
There's no gravity up there. There's nothing to push off of.
They don't have to work as hard to move.
And yeah, they don't have to work as hard to move. So what would possibly happen is their bones are going to reshape themselves just because they're not being put through the different types of stresses. Okay, so enough of that. What I want you to do, I think on that page that you have in front, is that vocab terms or is that, well, I got a handout here. That, yeah. Okay, so what I would like you to look at then is what you'd see. 1, 2, 3, what was that? Page 4 then, be the back side. It has blood cell formation on top, but we got a whole list of terms and bones to know there. And I just want to quickly double check on the page number. It says 217 to 226. Okay. I think that's going to be pretty accurate. Okay. Yes, so it starts here on page 276. And again, one of the things we said yesterday, when you're looking at this is the frontal bone. Don't associate the frontal bone with what? Right. That's our bird example. I said, when I took that ornithology class, I knew that was a shoveler duck because it was on the corner of the desk, not because of its color. Okay, so what do you feel works best for you? Is that where you look at these pages and work with these models, or do you think it's beneficial to work together as a group and just go through where they're found on a 3-dimensional model as opposed to a 2-dimensional model in your book? What do you feel works for you? Now, is that where, do I point to these and say, what is this? Or do you want to have this pointed to it and tell you what it is? Well, this was handed out to you yesterday. What have you been doing?
Basketball.
Playing basketball. Yeah.
We didn't want a manual diagram exam we were doing.
Well, one. Yeah, and that is open for not discussion, but what's the right word I'm looking for? Not discussion, but maybe it won't be on Thursday. I think with it being Tuesday, that's kind of a quick turnaround. Okay, so I think maybe the best thing to do then is, yeah, when you say both, that's fine. Yeah, that's what we want to do. Wouldn't that be scary if you all of a sudden saw it go like this? Yeah. Okay, anyway, so let's just go ahead and go right on down the list. That's fine. Okay, so zygomatic bone, okay? That's what you're going to find right along here, okay? That's this, if you want to call it arch-like structure, if that's what you want to say that is. Okay, I wonder, since we got these, rather than just standing and looking a long ways away, toss it or just slide it? Okay, some of these, the joint may have come a little loose. Okay, and it's got that spring load on there. And this guy lost his mind, I think. Guy, gal, oh, that might be a female. I guess yeah, we'll go with that. Who gets to hold the model? You want me to throw it or just set it down?
Whatever you prefer.
Who can catch then? Throw it to Reese.
Nice.
Uh-huh. Okay. So as we're going through this then, all right. So the zygomatic bone, as we said, is this arch. That's what you would see here. Okay? The frontal bone, just what it says. Up here, this is your frontal bone, and it's also right here. Should you, like we say in class, I ask a question, you're gonna, if I tell you the answer, you're going to say, God, I knew that. You're hitting your frontal bone. Okay? And then just by looking at external auditory meatus, what do you suppose the clue is there? Okay? So where do you think would be the best place that you're going to see that auditory meatus? Yep, right here. And it's going to be an open channel that in certain cases, yeah, if this fly swatter was thin enough, stick it through here and pull it out the other side. Yeah, yeah, okay. It's a little opening right on this temporal bone. And reason I say opening, it's really not that obvious to see, maybe. I don't know, but just look for probably a hole right behind this coracoid process, I think. Yep, that's correct. Right behind where the jaw has a hinge, the back portion, one of these is a condyloid process, and one of these is a coracoid. I think this is the coracoid. Okay. So the next one we see is the condyloid process. I want to make sure that that's correct before we get too far. Yes, the coronoid process is up front here. Okay? So on this mandible, the front portion is called the coronoid process. Okay? And then going down the list, it's right here, the mandible, this front projection right here. You got two of them on the mandible. That kind of looks like this. That is correct on that blue structure, but it's the front one, not the back one. Okay, so coronoid process, or excuse me, condyloid.
Right here, right?
The front one, yes. Okay, and then the maxilla. Okay, that is right here or right here where these actually fuse. You have a left and a right maxilla. So to look out in front of you people, you would have, this would be, if we turn it this way, okay, this is your left, this is your right, because I'm looking at a mirror image if I'm looking at you this way. But, okay, just like for yourself, remember sometimes you're looking at a mirror image. But in this case, since this is pointed forward, we can say that's the right, that's the left. But if you're looking at it in this direction, you have to say that this is the left side, this is the right side. Because remember, sometimes you're looking at a mirror. Does that make sense? Just like in our chemistry class yesterday, I said, left side. Does that make sense? I know it's my right, but in that mirror image, that's the left side. Okay. Perpendicular plate to the ethmoid bone. That is underneath here, and it's part of the palate. It's, you could say just what that means. It forms a perpendicular plate. In other words, a perpendicular angle is right angle, correct? So you would actually have to see a cross section of that. You really can't see it very here. We can just point to about where it's at, and it's on the roof of your mouth, but it's above that. You really can't crack this skull open to see it. You have to see a cross section of it. Okay? Excuse me. Okay, a suture is a type of joint in the skull, okay? Or cranium, if you want to this whole thing is a skull, but the upper portion is called the cranium, okay? But in this case, there's three types of joints in the body. You have freely movable, that's this, okay? This is a freely movable joint. A slightly movable one would be your vertebral column. It's not quite as flexible, but you have some movement. And then an immovable joint is these sutures that lock these bones together in the cranium and skull. So what we see here, the sagittal suture, is just this zigzag line that locks these bones together, okay? It's between what we call these two parietal bones. There should see a zigzag line that does that right here. That's called a sagittal suture, okay? Then the next one is the coronoid process. And again, I want to make sure that we get this correct. No, I don't see that on here. I actually had that backwards. This one up here is your coronoid process. I said it was condyloid, but this is your coronoid process, okay? So that next one down, this is your coronoid process,
Yeah, a little closer.
okay? This guy right here.
This is coronoid.
Yep.
And then which is the?
The back one is the mastoid process. We haven't got that far yet. So this one is the coronoid process. This one right here. Okay.
Which is coronoid then?
We haven't got that far yet. Okay. The coronal suture. I think the best way to look at that is just picture a C like this for coronal. Tip it sideways, okay? Take that, tip it sideways, and it locks your frontal bone with your two parietals here. Because remember, this suture here is called your sagittal. And the one in front of there is that C that we talked about. Tip it sideways, and it locks that frontal bone with these two parietals. That is your coronal suture. Okay?
Mr. McKay,
Yes?
What's the condylar process then?
We haven't got that far yet.
Well, it's
That's the one you thought was coronoid.
Oh, okay. It might be more evident in a different view, so just remind me to go over that, okay? Okay, so coronal suture, the vomer, there again, that's back here. It actually creates a V like this, but it's upside down, and that is actually behind that perpendicular plate of the ethmoid bone. You can actually see the vomer here. It's this guy. It's behind the perpendicular plate. Yes, that's your vomer right there.
Little line.
Yours, yes, that is the vomer. Yep. All right. Then, now, we're going to skip that frontal fontanelle for right now because fontanelles are found in infant skulls, okay? The reason we say that is for anyone who's ever held an infant